All right, so if we have a question that asks based on the distance, right, that an object fell, okay, so I'm dropping something from rest, if we know how far it fell, can we calculate the time that the object fell, right? So how long was it actually traveling? Okay, so this is a really useful video, especially for working on that reaction time labtivity. So to do this, I'm just gonna skip to the point here. We'll use this kinematics equation because it contains all the pieces that we need, right? We've got our change in distance. We have the acceleration. We actually know what the acceleration is. It's falling. The acceleration due to gravity should be 10, right? And the only variable that we're missing in this case is the time, right? The change in time. So as with all things, we can start off writing what we know. Okay, so based on these questions, we're going to know the distance that it fell. Based on these questions, we're also going to know the acceleration due to gravity. Okay, and so the only thing that we're really missing here is our time, right? Our change in time. Now, I don't actually have a real question here, so I'm just going to kind of throw in some variables and we'll just kind of make it up as we go along, right? So let's say that an object fell 10 meters. Let's make it fancier. Let's make it 15 meters. Okay, so if an object fell 15 meters, right, and if we're dropping it from rest, that reminds me, we actually have our initial velocity, right? If we drop something from rest, we know it has to start at 0 meters per second, okay? And if it's falling, we know that its acceleration due to gravity is going to be 10, okay, 10 meters per second, right? So every second that it falls, it's going to go 10 meters per second faster. Right? Okay, so when we're setting up our equation, again, the only thing we're missing is time. I'm just going to plug in everything that we have. So my change in position, we said it fell 15 meters. We don't really, we have the initial velocity. We don't have change in time. Okay, then we have half the acceleration, so that's equal to 10, multiplied by time squared. Okay, so this might look a little more complicated, but remember, we can actually eliminate this whole chunk, okay, because we know if it's starting from rest, anything 0 multiplied by whatever is just going to be 0. So we can actually get rid of this whole thing just to kind of simplify our work. Okay, so really we're just kind of setting up this equation. And then we got time squared, right? That's our unknown. Okay, so from here we can just simplify where we go. So we got 15 meters. 1/2 multiplied by 10 is 5. So 15 meters is equal to 5 times time squared. Okay, let's get t squared all by itself. So divide both sides by time. We end up with 3 is equal to t squared. Okay, and then to find time all by itself, we just have to find the square root of both sides. Okay, so let's plug in our trusty calculators. Square root of 3 is equal to 1.73. Okay, so 1.73, and that's equal to time. And because it's equal to time, then we should have our units in seconds, right? So if I drop something from rest from a height of 15 meters, we know the acceleration due to gravity, it'll take 1.73 seconds to reach the bottom. Okay, so again, this is really helpful, especially for the reaction time labtivity. We can simplify this equation to its bare bones, where if you have the change of position, that should be equal to half the acceleration multiplied by time squared. Again, we can omit this whole thing if it's dropped from rest. Okay, so I hope this was helpful. If you have any other questions, please let your teacher know, and thanks for watching.